Hi guys, let's recall about the octet rule. The octet rule is achieved when a stable arrangement is attended, which the atom is surrounded by 8 electrons. In this lesson, we will study molecular situations that do not obey the octet rule. These exceptions of octet rule fall into 3 categories. First, molecules with incomplete octet. Second, molecules with an expanded octet on the central atom. And finally, the molecules with an odd number of valence shared electrons. Let's look at the incomplete octet first. It occurs when the central atom has less than 8 electrons in its valence shell. These elements can exist in stable compounds forming bonds with less than 8 valence electrons. The central atoms with this incomplete octet most often occur in beryllium, boron, and aluminium. An example for incomplete octet molecule is BeCl2. Its structure here is already in stable configuration even though it only consists of 4 electrons around beryllium. This is because beryllium has only 2 valence electrons, and though it does not fulfill the octet rule, it is likely the best structure possible. More common than incomplete octets are expanded octets, where the central atom in a Lewis structure has more than 8 electrons in its valence shell. Expanded valence shells are observed only for elements in period 3 and beyond with an empty 3d orbital. We will use SF6 as the example. As we look at the Lewis structure, it has 6 covalent bonds with 12 electrons around S, which exceeds the 8 electrons of octet rule. After all, this is the most stable Lewis structure of SF6 in expanded octet. Next exception to the octet rule is when there are an odd number of valence electrons. It occurs when central atom contains an unpaired electron in its valence shell. An example of a stable molecule with an odd number of valence electrons would be nitrogen monoxide. Nitrogen monoxide has 11 valence electrons and nitrogen as the central atom. There are 3 electrons, which is odd electron in nitrogen, but this Lewis structure will bring both the nitrogen and the molecule's overall charge to 0, which is the most ideal for a charge situation. That is exactly what is done to get the correct Lewis structure for nitrogen monoxide, even though it is not obey the octet rule.